age squared. So this is purely based on my domain knowledge. So I know that medical expenses will increase exponentially based on age after a certain point, and hence I am using the variable age squared. I am adding it to the linear regression model. So when a variable such as squared gets added to a linear regression model, the model becomes a non-linear regression model. So we have seen y equal to mx plus c as simple linear regression, and y equal to c plus m1 x1 plus m2 x2 plus dot 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 plus mn xn has multiple linear regression. So then for non-linear regression, we will have square or probably higher values for x. So here we are using age squared. So the variable x1 will become x1 squared, and hence the regression equation becomes a non-linear regression. Also, based on my domain knowledge, I know that BMI after a certain point will result in an increase in medical expenses. That is, until the BMI is 30, BMI won't influence the medical expenses. But once BMI starts going beyond 30, it will result in a significant increase in medical expenses. Hence, I create a binary variable called BMI 30. That is, if BMI is less than 30, it won't have any impact on my medical expenses, and hence BMI 30 will be equal to 0. If my BMI is 30 or more, then it will impact my medical expenses significantly, and hence BMI 30 is a variable which will be assigned the value 1. We will achieve this by using if else function, that is a ternary operator in C. If you people had studied C, you should have come across something called ternary operator. It's quite simple. That is, in this function, I am checking whether BMI is greater than or equal to 30. If this condition is true, then the second argument will be assigned as input to the variable BMI 30. So if the BMI is less than 30, then the value 1 will be assigned to BMI 30. Sorry, if the BMI is greater than or equal to 30, then the value 1 will be assigned to BMI 30. If this condition becomes false, that is, if BMI is less than 30, then the third argument will be assigned as input to BMI 30. If BMI is less than 30, then the value 0 will be assigned to BMI 30. So we are planning to add two variables, namely age squared and BMI 30 to the existing model. But we don't know whether age or BMI values are not required or not. That is, based on our domain knowledge, we know that if we convert age to age squared and sorry, if we introduce variables like age squared and BMI 30, the model will be more accurate. But that does not mean that age or BMI are not statistically significant. So we will have the old as well as the new variables. Once we build the new model based on the summary value given by the new model, we can find out whether the old variables are still significant or not, and then remove them if they are not statistically significant. So we are going to do one more change based on our domain knowledge, which is nothing but bringing in interaction effect. What is interaction effect? So long we have been seeing univariate analysis, that is, how is the relation between an independent and a dependent variable. Now we are going to see the correlation between two independent variables and the dependent variable. So when more than one independent variable is involved, then it becomes bivariate analysis. So in interaction effect, two independent variables will be interacting, and we will study the effect of such an interaction. Based on my domain knowledge, I know that if a person is smoking and has a BMI above 30, that if he is obese too, then the medical expenses will increase significantly compared to the sum of both. That is, let's assume that if a person smokes, his or her medical expenses will increase by $5,000, and if a person is only obese, then his or her medical expenses will increase by $1,000. If a person smokes and is also obese, his medical expenses will be more than the sum of the two, that is 5,000 plus 1,000 equal to $6,000. It will be more than $6,000. Hence, I am introducing the interaction effect into the model. So how will I introduce interaction effect? I will use BMI 30 into smoker, a new variable. So here star or into is used in order to include all the variables, that is BMI 30, smoker yes, and the interaction between BMI 30 and smoker S. Why? Because I know that BMI 30 and smoker S interaction effect will be statistically significant with respect to expenses, but I am not sure whether BMI 30 and smoker S individually are not statistically significant. So I include all the three variables as we did for age and BMI. If the new model says that one or more of the old values are statistically insignificant, that is, they have less than 3 stars, then we can ignore them. The colon symbol indicates interaction effect, BMI 30 colon smoker S, but only when we use star symbol or multiplication symbol, all the three variables will be included. If we use colon, then only BMI 30 colon smoker S interaction effect variable will be included. BMI 30 and smoker S variables individually won't be included, which is wrong. Hence, we are using star or multiplication symbol instead of colon. Now, let's summarize what we did so far. So we have created three more variables, and we are going to add them to the existing model. What are the three variables? Age squared, which is a nonlinear term for age, BMI 30, which is a binary indicator for obesity. That is, BMI 30 can either be 0 or 1, depending upon whether the BMI is less than 30 or greater than or equal to 30, respectively. And finally, the interaction effect variable, BMI 30 and smoker S, which is represented by BMI 30 star or into smoker yes. So these three variables will be added to the existing model. So in the existing model, we have uh, age, children, BMI, sex, and region. Age squared, that is age. Here we cannot create a variable age squared, and hence we are naming age squared as age 2, and the interaction effect variable BMI 30 into smoker are added. Why are we not adding the variable smoker? Because BMI 30 into smoker will add smoker, BMI 30, and the interaction effect variable BMI 30 into smoker. So it's enough if we just mention BMI 30 into smoker. So having added the new variables to the model, let's see how the new model looks like and by what extent it is better than the existing model. As you can see on the screen, insurance variable has 6 independent variables and 1 dependent variable, the input that we have given in the form of a CSV file. Now, after executing the command age squared, that is insurance of age 2 is insurance of age squared. We are assigning the value age squared to the variable age 2. Now you can see that a variable called age 2 with the square of age values is added to the model. Added to the insurance variable. For example, in the first row, age is 19, and we have the last column age 2, which is the square of 19, 361, and so on. Similarly, we are now adding the variable BMI 30 based on the output of the if-else function. That is, if BMI is greater than or equal to 30, BMI 30 will be assigned the value 1, and if BMI is less than 30, BMI 30 variable will be assigned the value 0. Now, the insurance variable has one more column appended at the end after age 2, that is BMI 30. So in the first row, we have BMI as 27.9, which is less than 30, and hence BMI 30's value is 0. For the second row, we have BMI value as 33.8, which is greater than or equal to 30, and hence BMI 30 value is 1, and so on. So now we have created the new model with additional variables age 2, BMI 30, and BMI 30 into smoker. Let's see to what extent is this model more accurate than the previous model. That is, this is a nonlinear regression model, and let's see by what extent is this nonlinear regression model better or more accurate than the linear regression model which we saw some time back. As highlighted on the screen, you can see that the adjusted R-squared value is 0.8653. If you convert it into percentage, you will get 86.5 or approximately 87%. If you remember, the adjusted R-squared value for the linear regression model was approximately 75%, that is 74.94. So what's the difference between 75 and 87? It is 12%. So by introducing new variables based on my domain knowledge, I have increased the accuracy of the model by 12%, which is quite a good or significant increase. So now let's see what are all the statistically significant values. We can see that age 2 is statistically significant. That's obvious. That's why we have added it. We have children, which is statistically significant, BMI, which is statistically significant. BMI 30 is not statistically significant, but BMI 30 interaction smoker yes is statistically significant. And we have region southwest and smoker yes as statistically significant variables. So from this new model, we find that the old variable age is no more statistically significant and hence can be removed from the model. Also, we infer that the old variable BMI is still statistically significant and cannot be removed from the model in spite of introducing the variable BMI 30. Though BMI 30 is not statistically significant, BMI 30 interaction smoker yes is statistically significant and hence we cannot remove BMI 30. So these are some of the inferences that we can draw by looking at the values of coefficients, that is the number of stars of each of the independent variables, including the dummy variables and the new variables that we have added. So we can see one more thing. So based on my domain knowledge, I said that the sum of the values, that is if a person is obese and is a smoker, then the expenses will be more than the sum. Here we have BMI 30, that is for an obese person, the expenses will be 997.9 or approximately $998 lesser compared to a person with BMI less than 30. And for smoker yes, we have the value as $13,404.5 more than a person who doesn't smoke. Its sum will be a value 12,000 something, that is approximately 13,000 minus 1,000, which is 12,000 something. But if you see BMI 30 interaction smoker yes will result in the increase of expenses by $19,810.15, which is more than 13,000 minus 1,000, which is $12,000. Hence, my assumption based on my domain knowledge is correct. So just to quickly summarize what we have seen, we have seen an interesting real-time case study used to predict the medical expenses of a person or a patient and to predict customized insurance premium values based on the predicted customized expenses values. So though we knew earlier that linear regression won't work because